Hi, this is Pawan. In this video, we'll solve another important sliding window interview problem. Given a string and a number k, we need to find the longest substring that contains at most k distinct characters. So let us understand step by step. So for example, if the input if the input has equal to eceba string and k is equal to 2 and then output would be 3. So here, so first of all, like what does the most k distinct characters mean? It means a substring can contain one or two different characters, but not more than two. So let us look at the string eceba. So the substring ece contains only two distinct characters, that is e and c, and its length is 3. If we try eceb, it has three distinct characters, that is invalid. So the answer is 3. So, so one simple approach is to try every substring in this string and count distinct characters each time. But that would take too long for big strings. So we use sliding window. In sliding window, we follow two pointer method, that is left and right, and the right pointer expands the window and we store character frequencies in a hash map, and if a number of distinct characters becomes greater than k, we move left forward until the window becomes valid again. The window is valid as long as map size is less than or equal to k. So let me write a method that gives us length of longest substring with k distinct characters. So So this method returns the length of longest substring, k distinct characters. So let me write an edge case. If string equal to null, or else string dot length equal to 0, or number of distinct characters equal to 0, then return 0. This is an edge case. And let me initialize three variables. First one is map, that stores some character frequency. Map that stores the character frequency. Let me take the inputs. Also, let me initialize the left pointer and the max length variable to store the maximum length of the valid substring. And let me write a for loop. So we add current character into the map and we increase its frequency. So here, if we take a for loop, we take char at right index and we put the same character into the map. And here in the map, if it does not exist, if the character is does not exist, then we put it in the map and we increment its count to the 1. And if it is already exist, we just increase the character count. And each time we'll check the map size. If it is greater than k, k is nothing but distinct characters, number of distinct characters. Right? So we take here character. If the map is invalid, we decrease the count of the characters until it becomes 0. Once it becomes 0, then we remove it from the map. It has minus 4. So we increment the left so that it becomes the count becomes 0 and then we remove the character from the window. So if distinct characters become more than k, we shrink from the left, and when frequency becomes 0, we remove the character from the map. That reduces the distinct count. This is the most important part, and we update the max length. Previously, we initialized it to the 0, right? And each time we check for max length. So we take right minus left plus 1 as we discussed in our previous windows, which is length of the current window. Length of the current window. After fixing the window, we calculate the current window length and we update the max length. So we need to add a return statement here. And let me add a main method. Let me take this. So let me take input as a string, which is eceba and distinct value as true. Okay, so let me run this and I will debug and I will let you know. I will explain it one more time. And if you see, we need to get the output as 3. The max length here would be 3. So, and the time complexity of this method is big O of n because each character is added and removed at most once. So, space complexity is big O of k because map stores at most k distinct characters. So, let me debug this and explain it one more time because it is one of the most asked interview questions. And in this method, if the length is null, if length is 0 or the string is null or else a distinct characters is 0, then we return a 0 because it is invalid. That is for the edge case. And we initialize the variables, map variable left and the max length, and we take the for loop. In the for loop, we increment the right, we take the right variable and we increment towards the right. And if we take, first of all, let me, so if we step over, so the right index value would be 0 and the left would be 0 and the max length would be 0 and the map is empty. So first we take the character E and in the map, so first map is empty and if the map is empty and E is no value is present in the map. So we are adding character E to the map and we are putting its value as 1. So if you see, map stores the character E with the integer 1 and we are checking map size if it is greater than or greater than k distinct characters. So the condition is false. So again, the max length is previously it was 0 and the right is 0, left is also a 0, 0 minus 0 plus 1 that is 1 and the max length becomes 1 because the right most variable E is 1. Now again we increment it, right? Increment it. So once it gets increment, now the character becomes C. And if C is also not present in the map, now the count of C becomes 1 in the map. If you observe, map has only E. Now we are inserting C into the map. So now the count of the C becomes 1 and the map size becomes 2. Is that greater than K? No. Again, we check for max length. The max length previously it is 1 and the rightmost index is at 1. 1 minus 0 is 1. 1 plus 1 that is 2. Now the max length becomes 2. Again we increment right and E. Now the right value is 2 and the character is at E. E is already present in the map. So since it is already present in the map, we get the index or else the value of E that is 1. 1 plus 1, 2. And now its frequency becomes or else count becomes as 2. If you see, E value becomes 2. Now the map size still the map size, because it has only the two characters, that is C and E. So it becomes false. And the max length is 2. Right is also 2. 2 minus 0, 2. 2 plus 1, 3. So now the max length becomes 3. Now let right gets increment by 1 and it becomes 3 and the value is B. Map does not contains B, it contains only C and E. So it gets inserted into the map with the count 1. Now the map size, see B, C, E, which is map size is 3. So which is greater than distinct characters. So it satisfies this condition, and now the control enters into this line number 18, and we take the char at left. Left is 0. So the char at left is E. And we put that character into the map and we decrement its count minus 1. We decrement its count. So previously E is at 2. That is number of times E present in the map is 2. Now we are decrementing its count and we are checking if it is 0. If it is not 0, we are just incrementing the left one. Now the left becomes 1. And again, the map size is still greater than K. K is 2 and the map size is 3, that is B, C, E. Now again, left is at 1, 0, 1. C, it is C. No? So left carry is at C. And we decrement its count. Once we decrement its count, C becomes 0. C becomes 0. If the map dot get value of equal to 0, we remove that character. So we remove that character. See, now we remove character C. Again incrementing left. And now it becomes false. And still max length is 3, right is 3, left is 2. 3 minus 2 is 1, 1 plus 1 is 2. And the max length is 3. 3 and 2. Max is 3. So max length becomes, again we increment the right. Now right value is 4. 0, 1, 2, 3, 4. So now right is at 4. That is character A. Character A is not present in the map. So we add that character A to the map with the count value as 1. And now the size of the map again becomes true. So once it becomes true, and we take the caret left hand, we take the caret. So if we take the caret left, that is E. Left is at 2. 0, 1, 2. So the caret left is 2, and we decrement the value of E. If we decrement the value of E, it becomes 0. Once it becomes 0, we remove the character E. And once we remove that character E and we increment the left again, and now the map size becomes again less than K, so it is invalid, and it is not satisfying the condition. It comes out of the while loop, and again it checks for max length. Max length is 3, right is 4, left is 3, 4 minus 3 is 1, 1 plus 1 is 2, and max of max length and this current window length again becomes 3. Again, now right is at 4. Again, if we try to increment, so it is at 4. If it gets increment, right becomes 5, and length is also 5. 5 less than 5 is false, so it comes out of the loop. Max length is 3, so it returns the max length. So that is the answer. So this pattern is very powerful. Once you understand sliding window, many string interview problems become easier. Hope you understand. Thank you.